이번에는 CCO님께서 발표 진행해 주시겠습니다. Please welcome Mr. David Bennett, CCO of Ten스토렌트, to the stage with a big round of applause. 여러분 다시 한번 큰 박수 부탁드립니다.
Hello everybody, thank you very much for having us today. So, first of all, my name is David Bennett. I'm the Chief Customer Officer at Ten스토렌트. First and foremost, I'd like to say that Jim Keller was hoping to be here, and my colleague Keith Whittick, who's the COO at Ten스토렌트. Unfortunately, they weren't able to come, but they did ask me to send their regards. Korea is a very important market for us, and we've had, if I look at our 6 or 7 year history, I'll be talking a little bit about it today. But we've had a lot of our initial success and frankly a lot of support from people in the country. So on behalf of the Ten스토렌트 executive team, we'd like to thank everyone here for joining us today. Also, before we begin, first of all, I appreciate everyone coming out today, but I'd like to thank the earlier speakers on the stage. So Manikoursoft, I've been working with them for years, and their liquid cooling solution, I think if I look at the challenges in AI, and some of the solutions that we need to make a more efficient system, I'm really pleased with what they're bringing to the market, and I'm really glad that we have the opportunity to work with them. So a huge thank you to Manikoursoft. And then we saw a memo from More. More is an extremely strategic partner for Ten스토렌트. We've been working closely with them, I think since a little after I joined. So the More team, really pleased with, they're a very talented team, and I think the contributions that they've given to Ten스토렌트 and what they're trying to do. I looked at the slide at the end, and their approach to AI matches and lines up very nicely with what Ten스토렌트 believes. And again, very talented team. I think their contributions have been great, and frankly, they pushed us to be better. And they made a comment around hardware and software designing together. And I think if you look at Jim Keller and the team we put together at Ten스토렌트, we're very much a hardware team. And I think the More team has been teaching us how to be a better software team as well. So thank you very much to the More team as well. So I'll tell you what, I'd like to start, let me tell you a little bit about Ten스토렌트, and I'll tell you a little bit about what we're doing today, and what we're going to be launching here in the next couple months. And if you have any questions at the end, please feel free to ask me. Okay, so for those of you that don't know, Ten스토렌트, we've been around since 2016. If you look at us, we're actually becoming a fairly large company. We've got offices all over the world. It's also interesting to note our foundry partners. We work very closely with global foundries, with Samsung, with TSMC, with Rapidus. We've got good relationships with all of them. But our recent announcements have been our next generation products will be coming with Samsung, so we're excited to announce that. And then if you look at our offices, we started in Toronto, Canada. But today we have our big offices are in Toronto, Austin, Santa Clara, and then with offices around the world. And most recently last year we opened up the Korea office. I don't know if I'm allowed to talk about this yet, but we're starting to hire, we want to hire an engineering design center in Korea as well. So we'll be, in the next couple of months, we'll be looking for software engineers. I think we've already got some CPU engineers starting, so be on the lookout for that. Finally, if you look at where we are in our journey, so we are currently, most recently we raised a Series C a couple of years ago. I think we raised about $400 million. We'll be announcing our Series D soon. So if you look at where we are, Series D will be closing soon. And what I can say is that Ten스토렌트 is going to be well funded over the next couple of years to continue on our mission to bring AI and high performance compute. So that's where we are today, and thank you very much for your support. One thing about Ten스토렌트, we're a startup, and with startups usually you have a great founder with a great idea. I think one thing that sets Ten스토렌트 apart, a little unique, we have a lot of experience in hardware. Obviously under Jim Keller, who's a renowned high-performance CPU architect, but between Keith and myself and the team we put together, hardware is hard. It really is, it's in the name. And I think that one thing that, especially hardware startups, I think that the challenge is they underestimate some of the challenges of bringing hardware to market. The funny thing is when you're selling $1 million of dev kits or $800 million of Galaxy servers, it still takes a lot of infrastructure to make work. You need export control, you need supply chain, you need support. There's a whole infrastructure that needs to be built. And what I can say, the team at Ten스토렌트, we have a lot of experience developing hardware, We have a lot of experience bringing that hardware and software together. But I think in terms of AI hardware startups, this experience is proving, I think, to be one of the differentiators. So between Jim, obviously, Keith, and myself, I think we put together a team we're proud of. It didn't say on the last slide. When I joined 2.5 years ago, we had about 350 people. Today we've got about 500 coming in. I think we'll probably be 600 people by the end of the year. And as I said, I hope to have 20 people here in Korea in the near future. Okay, so let me talk a little bit about what we do, and I'll go into these in more detail after. So, I think when we speak with our customers or investors, Jim likes to cover this slide in detail. I'll be brief. We have a world-class team. It starts with Jim, but we really put together probably one of the best CPU teams on the planet, and we put together a team of AI, hardware, and software engineers that have been doing this for 7 years. We are on our third or fourth generation of hardware, and our core technologies are as follows. We're building an AI engine that our new version is called TenSix-Neo. We're building the highest performing RISC-V CPU on the planet with Jim's team under RISC-V, the Ascalon processor, and we're building the software to bring this all together. So we take this AI architecture, we take this CPU RISC-V architecture, we take the software, and we put it into the products in the middle. So the products that we bring to market are IP. So we currently have customers who are purchasing both our AI and our RISC-V IP. We take chiplets, and we build this IP into chiplets where we go and make our own hardware. We take the chiplets, we turn them into SoCs, and then we take these SoCs and we put them in the servers. I'm going to go a little off script here. So sometimes I get questions. I think I have some investors in the crowd, and they say, Tenstoren, why are you doing so much? You're a startup. You need to do one thing. Just do one thing right. You're talking to me about IP, about RISC-V, about AI, about servers, about software. Maybe you're doing too much. This is what I like to remind people. Our hardware, so we build Galaxy servers, we build Blackhole, we build our AI accelerator. To build that hardware, let's look at what we have to do. We have to create the IP. So we create the AI IP. We choose to put high performance RISC-V because we believe the combination of compute and acceleration is important. We take that IP and we put it into chiplets. We put chiplets, we combine them together into SoCs. We take the SoCs, we put them on boards. We take the boards, we put them in servers, or workstations, or Galaxy modules, and then we build software. So, to create the hardware that we're selling today, we have to do all of these steps. Anyways, we have to go build the IP, we have to go build everything else. The difference between us and NVIDIA, or the difference between us and ARM, is we're able to monetize every step of the way. I can sell my IP, I can sell my RISC-V, these are all things we would have had to do anyways. I'll give you an example. ARM is an IP company. If ARM started to sell hardware, they would upset many of their customers. In fact, that kind of is what's happening right now. They're upsetting their customers, they're getting into hardware. Conversely, NVIDIA, Intel, AMD, they sell a little bit of IP, but they have a huge hardware business that they don't want to upset, they want to protect. So I think one of our opportunities is we don't have that legacy business, we're not afraid of competition, and we're able to take all of our steps along the way to build our hardware and monetize them. We don't have any of the legacy issues. And what that means for the customer is we're able to offer technology in any way they want. So I think it's actually, when people ask me, are you doing too much? I actually think that's not the case. I think it's one of our advantages that we're able to do this. I think one of our big advantages is we're able to do it in-house. Finally, our market. So you look at where our verticals are. Data center is where most of our customers are today, and we think the biggest opportunity. We've had a lot of experience and I'd say success with automotive. Obviously here in Korea with Hyundai, but we have a strong automotive team, and you'll be seeing more announcements later this year. And then client IoT, and a huge number of partners. And I think you'll see that one of Tenstoren's main missions is to build an ecosystem of partners that's working together with us. It's why we're doing open source software, it's why we're doing open standard RISC-V. We really want to build out this ecosystem. Okay, let me go a little bit deeper into what we're doing. So we talk about the different products that we build. So we build our TenSix-Neo AI IP, our RISC-V Ascalon IP. We scale from very small cores to very big cores, and we have a modular design which enables us to sell the right amount of compute for the right product for our customers. We then take the IP and put it into chips and chiplets. We have a portfolio of cards that we make, and our hardware, I'll talk about that today, is focused at the data center. But we do have customers that buy our chips, and will be buying our chiplets directly. We also take these chips and chiplets and we put them into our systems. So today we've developed the Galaxy server, which is our 4U going to 6U server today in-house, which we see again competing against NVIDIA DGX. And we build our own PCI boards, and this is where most of our hardware customers are purchasing. And then on the software side, we have two software stacks. We have a top-down general compiler, and then we have a bottoms-up close to the metal stack. And I think our friends at Moray were talking a little bit about that, and I'll talk a little bit more about that at the end of the presentation. So these are all the products that we build to make our business go. And then we look at where our advantages are. Where do we think our differentiation is in the market? So very simple. On the AI side, I think we had a slide on his presentation as well. Many companies choose to do inference only, or vision only, or LLM only. Our hardware is designed to do inference and training, CNNs, LLMs, across the board, all types of AI models. As I said, we have a top-down general compiler, a bottoms-up bare metal stack, and one of our key differentiators is the seamless scaling across the core. So we use an Ethernet fabric to drive everything together. On the other hand, we're developing the world's highest performing RISC-V CPU. Probably one of the best CPU teams on the planet. It's a scalable design that goes from 2 wide to 8 wide. It's optimized to work together in AI, and we've also made it customizable so that it's easy for our customers to customize without us spending too many resources to do so. What this results in is we've got an architecture that works together. It removes the need for Mellanox switches, for PCI links, no switches, no routers, no hosts. We can do everything inside the silicon, inside the system itself, saving cost, money, driving efficiency. And our architecture is very different than a GPU. So we look at a GPU is a great product, but GPUs weren't designed for AI. GPUs happen to be good at AI. They do things in parallel. They're very good at pushing pixels to a screen, and they've done a great job of pushing all the different compute required to drive AI. That being said, our AI architecture is designed from the ground up to be better at AI compute processing. So this is where I think our advantage is when we get these two to talk together. Finally, for those that are keeping score, it's not clear whether the transformer is the final destination for AI. So the ratio of compute to AI, we have a feeling that it could change, and we think having the right balance of acceleration and the right balance of compute is going to be important, and the ability to change this in the future moving forward, to adjust how much compute versus how much acceleration will also be important, and also somewhere where we can provide differentiation for our customers. So 24 was a big year for us. We had a number of announcements. I think the most important one, outside of customer announcements, is what we've done across our stack. So at the end of last year, we open sourced our bare metal TT-Metallium stack. Earlier this year, we open sourced our compiler, and we launched our dev kits, which are available online today. Tenstorentt is the only AI hardware company where you can go online, where you can go right now to our website. You can buy our card, it'll come to your house, you can put it in your desktop, you can go on GitHub, you can look at the software, you can try it all out yourself. Nothing's hidden, it's all in the open, benchmarks are available, you can actually go and try it yourself. I think this is unique in the AI hardware space today, and if I look at my customer base and my investor base, we actually now have many of our customers, before they even come talk to us, they have purchased our hardware, they've gone through our GitHub, they've looked at everything, and then they've decided to come work with us, and then they've decided to come invest in us. And I think for me, there's no more important justification from our customers to actually try our stuff and look at our software and hardware, and then decide to work with us. So you'll be seeing more announcements in the next coming months and even next year. But we will continue to drive open source and open standards and build an ecosystem around our hardware. Okay, I want to talk a little bit about our hardware roadmap. So I said we do IP, we do RISC-V, we do AI. Today I want to talk about AI hardware. As we said, I'll talk a little bit about our AI architecture, but we develop our own chips, inference and training on a single piece of silicon that includes both RISC-V cores and AI-10 cores with our software. We then take this technology and we put it into a number of products that comprise our portfolio. From the quiet box and PCI cards for developers, to a loud box that goes, it's rack mountable, that goes in enterprise systems, to our, what we call our DGX Compete, which is our ultra-dense galaxy. I'll talk a little bit about this in detail for each one. And then our goal is to be able to cover as many of our verticals and as many, scale up and down the stack as much as possible. So I think many of you have seen this before. This is our silicon roadmap. This is our AI architecture. I won't go into too much detail, but both of these are available on our website right now. And if you look over generation to generation, we've made some significant changes each generation. In every generation, the 1064, the AI, the AI compute is improving. On top of that, we've made additions in each architecture. From Grayskull to Wormhole, we added our Ethernet, which allows our scalability and our connectivity. From Wormhole to Black Hole, we've added these RISC-V cores to enable self-hosting, to enable compute that potentially can't be done with the acceleration. And then moving forward to our next generation, we'll be starting our first chiplet generation. So our future products, our future black holes, will be comprised of our AI chiplet and our RISC-V CPU chiplet. And how you combine these together, maybe you think about them as Lego blocks. You can take them and you can combine them together to create new products. We'll talk a little bit about it later, but our goal is to provide the densest compute per chiplet, per product that we can design, and we can fit them in standard packaging, thereby reducing cost and improving efficiency. So Black Hole right now is back in labs, it's powered on. As I said, we've now done 3 generations. We call it Gen 2, but 3 tapeouts. Black Hole is back in the lab, it's powered on, 1 spin. We haven't had any need to go back and redo, and we'll be having our systems coming back out at the end of the year. And we're on track to deliver Quasar and Aegis. It's in lab, the RTL is finishing up, and we're going to have it out next year. Okay, so if we look at our PCB roadmap, this is the cards, we call them our dead fits, that are available today. You can go online and purchase Grayskull and Wormhole. Available right now. By the end of the year, we'll be releasing our Black Hole, which is our next generation PCI cards. These are the cards that our system partners, for example here in Korea and also in the US, will be taking and building the new systems around. Each generation we try to maintain the same efficiency in terms of TDP, also reduce cost and also increase flops so that we always have a per dollar story that we believe is competitive in the industry. What I'd like to introduce today, how am I doing? Good. So what I'd like to introduce today is our loud box and our quiet box. For the record, I didn't name the products. So the quiet box is great because it's quiet. So Jim said we should call it the loud box. And I said, that's a terrible idea. But he's like, it's loud. So I'm like, okay, let's call it loud box. But surprisingly, the loud box is quite popular, as is the quiet box. But their mission is very simple. Our goal is to have the single highest performing flop AI computer that you can plug into a wall and put in your desk. This product actually is quite unique. Our competition doesn't have this much compute, or AI compute, that's available in a desktop tower format, nor that can be plugged into a regular wall outlet. So this is the purpose, and our goal is for developers or smaller companies or companies that want to have high performance, large AI models, but don't have a server infrastructure can do this, and the development infrastructure can be run off of these boxes. So these will be coming out here at the end of the year. And again, I'll talk a little bit about it in the next slide. But our goal is to have the highest flops in a system for the lowest price that can run a multitude of models. So these boxes here can run, for instance, 11.3.170D, can run large models on your table, plugged into a regular outlet. This kind of illustrates what we're trying to do. So if you look at this number here, this is the flops in each box. Our goal is very simple. We want the most flops with the best specs at the best price. Now you'll notice that sometimes because of the way our architecture works, we're much more efficient in how we use memory and how we use compute. We've also got the onboard compute inside our products. So we actually do not need to have as many threads. We're able to save a little bit here. But overall, if we look at our total flops and what's available in the system, we believe it will be industry leading. So we kind of talked about model performance. There's a lot of ways to measure a model. But if we look at how models come out of the box, if we look at a standard batch size versus what's available, again, in a system that can go on top of your desktop for the price that we're offering, we're going to have best in class across most major models. These numbers apply to Llama 3, 3.1 today. I think Llama 3.2 came out, so we have to go back and get that up and running. But again, the mission is the same. Across every model at this price point with these flops to have the best in class performance on all major models. Currently we're looking at inference. We're working with our partners like Mori to get training up and running, and we'll be having training announcements coming up at the end of the year and early next year. Galaxy. So Galaxy is our 6U, well it's 4U moving to 6U ultra-dense compute. The mission with Galaxy is very simple. We are striving to have the densest amount of AI compute in the smallest available form factor. So the biggest change is Galaxy until this year has been developed in-house by Tenstorentt. In the next, I think, starting today we'll be announcing, but this will be a redesigned Galaxy from our OEM partner. We're moving from a 4U to a 6U system with a host built in, and we'll have the most amount of flops in the densest amount of space available in the market anywhere. Tenstorentt's differentiator is primarily based around scalability, the ability to design these servers into different types of meshes and choruses. We have, not unlimited, but we have a huge number of connectivity available in terms of how you want to wire your systems together, depending on the model and the workload that you're running. So flexibility in terms of connectivity, scalability, and density of compute is what we're striving for with our Galaxy product. So I think there's a few details here, but up until today we've had our in-house built Galaxy wormhole. This has been, we've been doing a number of POCs, and this is available on our website. You can take a look at what we're running. The biggest difference as we move from our 4U system to our ODM redesign is they've done 3 major changes. They've cost optimized, which means the price of the unit has gone down. They've made it scalable, meaning that they're able to manufacture a lot more units very quickly, and they've made it data center friendly. So a lot of our original design was very innovative, very interesting, but when you try and put it in a data center, it was a little clunky. This redesign is data center friendly, standing following industry standards, and we've taken the host node, which was separate, and we've included the host node in here. So pound for pound, this 6U should be comparable against the Galaxy, against the DGX, and our goal is very simple. In the same amount of space, we want more performance at a lower price and the same power profile, and that's what Galaxy delivers. Interestingly, we will have our black hole Galaxy out at the end of the year. As I said, it's back in the lab. We've got it up in Toronto, up and running now. We're doing final qualifications testing. We will also have a wormhole version of this Galaxy available as well. I expect most customers will be looking at the black hole version, but wormhole, again, price performance, and if we look at some of the markets that wormhole can play in, wormhole is a great option for some of our customers as well. So we will have both a wormhole Galaxy and a black hole Galaxy. I haven't talked too much about software. I thought the More team did a great job of explaining sort of their approach, and they're leveraging this over here. But we've been doing software at Tenstorentt for 7 years, and I'll be very honest. I think the biggest challenge for AI hardware companies is software. There was a quote in the slides we just saw that said, designing hardware with software together is the best approach. I couldn't agree more. I think it's the only approach. And to be honest, we've learned our lessons at Tenstorentt. We have refactored, it's a fancy way of saying redesigned, our software 6 times. In the last 2 years, this is the approach we've settled on. I am absolutely confident, and the feedback we're getting from the ecosystem and our customers, this is the right approach. So the approach is twofold. We have a top-down general compiler that will run the majority of models from the majority of the different frameworks, PyTorch, Onyx, TensorFlow. We don't expect it to get the best performance available in the hardware, but the goal is to have iteration. So you can play with new models, you can try new models, you can try things out. When you're ready to deploy, we expect most of our customers to take it here. Metallium is a bottoms-up, close to the metal framework. We've redesigned it to be created in a number of different layers with many entry points. I'll talk about that in a second. But we have customers today that are building compilers on top of our framework, that are building PyTorch 2.0 integrations, that are building models on top of it. We have multiple entry points for our customers and our partners to have complete access to our hardware. It's all being done in open source. Hardware specs are available, and our expectation is that the flexibility and the programmability that Metallium allows is what's going to help us grow our developer ecosystem. So far, so good. We had a goal last year. We wanted, how much was it? In 2023, we wanted 100 third-party developers working on TenStorent hardware and software. We came in at about 140. This year, we have a goal of 400. We're currently at about 350 with a couple more months left. So this approach, having a top-down general compiler that allows a lot of iteration, playing around with new models, has been going well. And this bottom-up, close to the metal, easily programmable, close to the metal Metallium stack allows power users and users familiar with C, C++ to develop as close to the hardware as we can allow. And this is the kind of ecosystem that it enables. So by, we will create the low-level kernels, we'll create the closest to the metal layer, and we've got a number of layers on top that we're working with our partners such as Moray. We enable all the open source software stack in terms of schedulers or KVM or Docker containers, and then we support all the major frameworks available as well. So any way that you want to access our hardware, we're trying to enable. We think that one of the biggest barriers for AI hardware companies is to get users off of the NVIDIA CUDA ecosystem, right? It's a very sticky ecosystem. I think Moray's approach is interesting. They're trying to make it so that it's seamless. That's good, and that's going to be very successful. Our goal is to also make it that it's easy to program for and to leverage all the existing tools and frameworks that are available in the ecosystem to make it as painless as possible for new developers to come on and develop on our hardware. And our approach is going to remain consistent and has since we started. Everything we do is going to be open source. We're developing all of our products in the open, both the compiler and Metallium stack. We're going to be aggressively ensuring that our documentation is up to date, all of our white papers are up to date, and this will be done in real time. In fact, we've had a lot of contribution from our community to help fix our documentation, and we're going to continue to operate in this manner. And then we've got a very active community on Discord. We're going to be starting to reach out to more ecosystem partners this year and next. This is, if we look at sort of our partners, again, our goal is to foster a community of partners across the board, from RISC-V to AI, software, hardware. And I think, one thing, if I'm being very open, I've been very happy with the number of customers and partners that really want to see TenStorent succeed. And I pass that along as well. I look at, there's a ton of really great AI hardware companies out there, Grok, Sambanova, Rebellions here in Korea. And my goal is I want to see all of them very successful. And sometimes I get asked, well, do you see them as competition? The truth is I don't. I think if I look at the opportunity today, it's a huge market. And today, NVIDIA has 95% of that market and is taking a lot of the margin out of the ecosystem. So my belief is if a customer chooses Rebellions or a customer chooses Intel or AMD, what they're saying is they're willing to accept an alternative to NVIDIA. And if they're willing to accept an alternative to NVIDIA, that means I have a chance to go get them as a customer as well. So we're very supportive of our partners and our colleagues around the industry, and we're going to continue to drive this ecosystem. We won't talk about it today, but with our chiplet ecosystem, we have CPU chiplets and AI chiplets. I think you'll be interested to know, you'll see a lot of our theoretical competitors also working very closely with us to develop new products in the future. So more exciting announcements to come. Okay, the last one, I'm not going to go too much into detail. This is all available online, but I actually added these in when I saw some of the slides earlier, because I really like this, and I think this is true. If you look at TenStorent's mission, it's about scalability and modularity. So TenStorent has the ability at the IP level, at the core level, at the card and the system level, and soon at the chiplet SoC level to have a very modular design that enables expansion, and it enables a clean sort of framework for communication amongst the different chips. By removing all of the complexity around the different L1 and L2 switches, around how to get different GPUs to talk to each other, and making it a really simple grid array with communication and communication to all cores, and depending how you connect it together. Our goal is to make programmability a non-issue. And by doing this, not only enabling the core-to-core communication, but by enabling complete open access to how these cores operate and what they do, we believe that we will have not only more efficient AI models, but we think that the non-AI workloads that we can do on our architecture could be very interesting to explore. So we've had a lot of interest from HPC and a number of scientific and finance calculations based on the way our architecture is laid out. The second one is memory. If we look at memory, we often get asked when we're going to be doing HBM. If a customer wants HBM, we'll enable HBM. Our hardware, we're choosing not to use HBM, and the reason is simple. Our architecture is designed in a way that much of the compute can be done inside the device without the need to go out and hammer the memory. So NVIDIA has taken the approach of solving problem by throwing physics and money at it. They're saying, okay, we have a problem with our GPU. We need big memory to solve it. So we're going to put the world's best memory with the most expensive packaging, with the most complex, it's incredible technology. But with incredible technology comes a price and comes complexity. Our goal is to solve it with engineering and architecture. So we've developed a system that uses commodity, less expensive parts, does more compute inside without the need of going back and forth between memory. Therefore, we negate the need. We do not need to have HBM, and we're able to do it with less expensive, but still extremely efficient GDDR memory and what the SRAM is available in the device. And then, of course, through chiplets, we can always expand if we need to. But we think our approach, as Jim would say, it's a more beautiful, it's a more elegant approach in terms of the engineering. And then finally, we talked about our programming, our programmability and simplification and programmability. Again, Mori's approach was quite interesting, right? They took all of TensorRT, CUDA, all the different programming models out there and tried to sort of unify them together. Our approach, in some ways, is very similar. We want to avoid this complexity as well by enabling full programmability into a simple and easy to program, core-to-core communication, but also allowing complete access to each of the compute units inside of our 10.6 core. So while we've used these in a certain way, we provide programmability to allow our developer community or our customers to design how they want the compute architecture to work. And I think this flexibility and programmability has enabled some really interesting use cases. So happy to talk more about this. It's all available on the website. You'll be seeing some more white papers come out later this year, maybe early next year. But I think that this open approach to not only open source software, but to open up the hardware is one of tenStorrent's differentiators and frankly one of our advantages. Okay, I think that's all I had today. I know it's a short time to do a big introduction, but as I said at the start, Korea was Korea's a very interesting market for us. It was the first market where we had our first IP sale. Some of our biggest investors have come from the Korean market, and frankly, some of our biggest fans. So my hope is as we grow the office in Korea and we grow our developer and our ecosystem community here, that we continue to have the support from the Korean ecosystem, and hopefully we can continue to grow our business and grow our ecosystem here together with you. And part of that is working with our partners here today, and I really appreciate all your time. Thank you very much.
Thank you for your presentation. 발표해주신 데이비드 베넬 CCO님 감사드립니다. 이번 시간에도 간단한 Q&A 세션 진행해볼 텐데요. 질문과 답변을 영어 통역이 제공됩니다. 강연에 대한 질문이 있으신 분들은 손을 들어주시면 감사하겠습니다.
발표 초반에 엔지니어링 디자인센터 소개하신다고 했는데 이거를 IP 비즈니스만을 위한 그런 디자인 센터인지 하드웨어 가속기를 판매하는 기술적인 도움이 좀 필요하거든요. 파트너들이 그리고 TT 엔지니어를 같이 고용을 하고요.
So the question was about the introduction of the engineering center in Korea that we're going to do next year, this year.
Yep.
The focus is going to be more towards to the development of the development of the software part, or is it going to be more commercial focus?
Yeah, good question. A number of roles. We started with a sales, marketing, and support team to support our customers. We also have, Korea has a ton of talent, so we actually have some CPU designers. My focus, however, for the center is some of the best AI software programmers I've seen come from Korea. So my personal goal is I want to build out that AI software team here first.
네, 먼저 1차적으로 지금 저희 목표는 이제 현재 계신 파트너들과 고객사들을 위해서 서포트와 그다음에 기술 지원, 마케팅 이런 역할을 담당하는 것도 있지만 추가적으로 텐스토렌트가 봤을 때 전 세계에서 가장 뛰어난 소프트웨어 개발자들은 한국에만 있습니다. 그래서 개인적인 목표로는 이 엔지니어링 센터를 AI 소프트웨어 엔지니어링 센터로 탈바꿈하는 것이 궁극적인 목표입니다.
또 다른 질문은 텐스토렌트가 하드웨어를 이제 개발하시고 소프트웨어를 개발하시고 모든 걸 다 하신다고 들었는데 그러면은 AMD 로딩과 인텔 옵션 API와 혹시 차이점이 같은 게 있을까요? 그러니까 텐스토렌트가 AMD 로딩과 인텔 옵션 API와 뭐가 좀 다른지.
So you mentioned that one key advantage of Tenstoren is that we build the software and hardware in-house, all vertical. Now, how does that compare to the other market alternatives like AMD or Intel solution?
So I've got lots of thoughts about it. AMD in particular tends to be a little weaker in software, just in general. But if I look at the alternatives, most of the alternatives are taking a Me Too approach to NVIDIA, meaning that they're building a GPU-like device with HBM, with complex packaging. And I think when you build a Me Too to NVIDIA, it's very difficult to compete. Whereas our approach, not just us, but some others, but especially Tenstoren, we've taken an approach with a highly differentiated architecture, and again, with that combination of high-performance compute, AI, programmability, and some of the architectural choices we made, I think our differentiation factor is much bigger than some of the other Me Too.
네, 지금 시장에 있는 다른 소위 말해서 경쟁자들의 제품을 보면요, 대부분이 엔비디아의 유형을 그대로 따라가고 있습니다. 상당히 복잡한 패키징과 그리고 비싸고 빠른 메모리를 조합해서 만드는 그런 솔루션들이 이제 엔비디아를 따라하는 소위 미투 솔루션이라고 생각하는데요. 이런 미투 솔루션의 약점은 결국에는 어떻게 한들 그런 컨셉의 원조인 엔비디아를 따라잡기는 어렵습니다. 방금 말씀하신 AMD 같은 경우도 그런 취지를 갖고 있는데요. 무엇보다 AMD는 또 소프트웨어 쪽에 좀 더 역할이라고 생각하고요. 저희의 장점은, 텐스토렌트의 장점은 이제 그라운드업으로 처음부터 이 AI 연대로 개발된 이런 디자인이다 보니까 그런 엔비디아가 하는 방식을 택하지 않고 저희만의 독자적인 방법으로 이제 하드웨어 소프트웨어를 개발해서 기존 시장에 나와 있는 것과 완벽한 차별점을 이룬다는 게 저희의 가장 큰 장점인 것 같습니다.
네, 오늘 발표 내용이 대부분 다 이제 IP부터 칩으로 이렇게 해가지고 데이터 센터까지 스케일링업하는 그런 내용을 주겠었는데요. 근데 로드맵에서 처음에 보여주셨던 카멘타는 시장 중에서는 이제 뭐 오토노머스 드라이빙, 자율주행 쪽이라던가 아니면 IoT 이런 부분도 있었는데 그쪽은 이제 디바이스 쪽 성능이 좀 많이 중요할 것 같아요. 근데 그런 내용이 안 들어가 있었어가지고 혹시 로드맵에서도 그런 내용이 좀 고려가 되고 있는지, 특히나 지금 전략적 파트너로 삼성이나 현대나 LG 같은 것들이 들어가는데 이런 것들은 데이터 센터도 중요하지만 실제 사람들이 들고 다니는 제품에도 칩을 원할 것 같다고 생각이 들었거든요. 이런 계획이 있는지.
We looked at the roadmap and we noticed that although you have companies like LG and Samsung strategic partners, there was not much mention about the on-device, like IoT, things like that. So does it account for much of your future plan, or what do you, or I mean, because we also believe that they also might require some sort of computing power.
Yeah. So the answer is it's simple. So Tenstoren is a little bit different than most companies because we are developing our own hardware and we have IP. So the hardware we're choosing to make is data center. You know, Jim Keller's a high performance guy who's doing high performance products. But our IP, we've designed both our AI and our RISC-V IP to be very modular. And I think that's where you'll see customers doing some very interesting things in terms of scaling down to device and scaling up.
네, 답변을 드리자면요. 우선 지금 저희가 보여줬던 로드맵은 저희 그 완제품 하드웨어에 대한 로드맵이었습니다. 그리고 당연히 이제 저희 완제품 하드웨어에는 저희 IP가 들어가고, 다만 저희 IP의 장점은 저희가 직접 개발하고 저희가 통제가 가능한 부분이기 때문에, 그리고 무엇보다 가장 큰 장점은 모듈화가 장점입니다. 저희 IP를 고객사가 원하는 대로 모듈화를 해서 방금 말씀하신 IoT나 다른 이런 용도에 쓸 수 있는 그런 강점도 충분히 지니고 있습니다.
Well, one thing that's interesting is, you know, I told you at the start, we have a very, very experienced team, right? We know that it's actually much easier to build a high-performance product and scale it down than go the other way. So our theory is start at the top, build the best performing CPU, you know, super interesting architecture on AI, and then scale down rather than the other way.
네, 그리고 저희가 서두에 말씀드렸던 것처럼 텐스토렌트 특히 CPU 개발진들은 전 세계에서 가장 뛰어난 인력들이라고 생각합니다. 그리고 저희가 경험상 저희가 배웠던 거는 한 제품을 이제 다각화시킬 때 한 제품을 가장 고성능 제품을 만들고 스케일 다운을 하는 게 쉽지 저성능의 제품을 만들어서 스케일 업하는 거는 상당히 어렵습니다. 그리고 저희는 지금 가장 높은 성능의 RISC-V 칩을 가지고 이제 그걸 모듈화시켜서 다른 용도로 사용하는 것을 권장드리고 있습니다.
There's one question there, one question there.
텐스토렌트 AI 칩이 워크스테이션으로도 쓰일 수도 있을 것 같고 데이터 센터에 그쪽으로도 대체할 수 있을 것 같은데 어느 쪽을 더 텐스토렌트는 중심을 두고 있는지, 그때는 아마존이나 마이크로소프트 데이터 센터에 있는 엔비디아 칩을 최종적인 목표가 그 칩을 대체할 수 있는 그런 것까지 타겟을 하고 있는지 그걸 좀 알려주실 수 있습니다.
Tenstoren's chips can be used both in a workstation setting as well as in the data center. He's wondering, is the Tenstoren's ultimate end game is to replace the existing NVIDIA hardware in their data centers? Is it considered to be the end game, or?
Our customers will tell us where our ultimate goal is. We are trying to make differentiated and interesting products where we see opportunity. So data center is a big opportunity, but it's not our only opportunity. So we have products there, and then things like the quiet box and the loud box. We actually think it's an opening because we don't see anyone else doing that kind of form factor with that kind of compute power in that space. So we're trying different things. We're going to iterate and try, but ultimately we're going to let the customers tell us what they want.
네, 아직까지는 저희는 저희 목표는 고객들이 원하고 고객들이 좋아할 것 같은 이런 제품들을 출시하고, 그리고 그 사용에 대해서는 고객들이 원하는 대로 하려는 것이 목표입니다. 그래서 아까 보여줬던 라우드박스나 화이트박스 같은 경우도 현재 시장에서는 대체할 제품이 아직 없는 걸로 알고 있습니다. 그래서 고객들의 니즈에 맞춰서 디자인하고, 그리고 궁극적으로는 그 시장의 흐름을 고객들의 니즈에 맞게 가져가는 게 현재 저희 방식이라고 생각합니다.
이거는 정부 차원에서 텐스토렌트 못들어.
Yeah, cool. So I actually have two questions. One is going to be quite fast. Talking about the Galaxy high density server, do you guys have any plans to make a water cooled version of that server? Because NVIDIA TGX is only available in air cooling option. So do you have
Short answer is, our design, we try and keep our designs to be, again, one of our differentiators versus NVIDIA is to be easily manufacturable and not kind of playing in the same complexity space that they do. But then we've got partners like Manikoorsoft here in Korea. We're very open to, if they want to take a shot at the design. And we've had a number of immersive cooling people approach us. Our design, we're going to try and stick to something that's easily scalable, but we're certainly open.
Yeah, and
지금 질문은요. 질문하셨던 거는 지금 저희 갤럭시 그 서버 같은 경우를 공랭식이 아닌 순행식으로 바꿔서 출시할 생각이 있냐. 왜냐면은 지금 엔비디아의 솔루션 같은 경우는 공랭식이 지금 전부입니다. 그리고 여기에 대한 텐스토렌트의 답변은 현재 텐스토렌트 차원에서는 기억하고 있지 않습니다. 왜냐면은 저희 텐스토렌트의 어떤 취지는 엔비디아와 같은 이런 복잡성을 지닌 하드웨어보다는 조금 더 간단한 방향을 추구하지만 또 반대로 지금 이 자리에 계시는 저희 한국 파트너분 같은 멀티코어 같은 이런 회사에서 또 매니코어 같은 회사에서 이런 순행 솔루션들을 개발하시고 또 저희 같이 판촉하시는 것 이런 부분도 적극적으로 권장드리는 부분입니다.
Yeah, the second question is related with the market because as you said, like Nvidia has like 95% of the current market. So with a company like Tensorent, the problems of supply and higher prices that Nvidia has, how do you think that NPUs will change that reality in the future?
Yeah. So I think it's a huge opportunity, right? The fundamental design, NVIDIA's approach is to throw physics and engineering, or physics and money, cost as a problem. Whereas I think we've taken a really engineering-first approach, and I think what it has enabled is a much lower cost base, but also we're not in the same. All of our parts, all of our designs are kind of off-the-shelf standard parts, so we're not in this fight for really specialized or complex parts. So again, I think Jim. Even if you look at our Ethernet fabric, I think Jim has a strong belief in simplicity, and I think having a simple, clean design is going to enable us to be more flexible in the future, both in terms of cost and supply.
네, 지금 질문은요. 현재 엔비디아의 이런 솔루션들이 우선 성능은 흠중이지만은 가격이 높은 것으로 지금 많이 알려져 있습니다. 그리고 그런 것들이 이제 시장의 접근성을 좀 방해하는 그런 요소들이 있는데 거기에 대해서 지금 이제 텐스토렌트는 어떠한 지금 그 입장이신지 여쭤봤었고요. 텐스토렌트는 지금 아까 서울에서 얘기했었지만은 엔비디아의 솔루션이 이렇게 되어 있습니다. 어떤 문제에 있어서 돈과 그다음에 복잡성을 문제를 해결했다면은 텐스토렌트는 이건 엔지니어링이라고 말씀하겠습니다. 그래서 지금 짐 켈러의 어떤 그런 지향점 같은 경우도 문제를 복잡하게 해결하기보다는 간단하게 해결하는 걸 원하시고, 그래서 텐스토렌트의 제품들은 대부분 모든 그 안에 들어가는 구성품들이 특별 제작이 아닌 일반 기성품들을 많이 활용하고 있고, 이더넷 패브릭 같은 경우도 기존 존재하고 있는 기술을 그대로 활용하는, 그렇기 때문에 저희가 가격을 현저히 낮출 수 있고, 그런 점들이 바로 전략적인 장점이 될 수 있을 것 같습니다.
한국에 센터를 설립하신다는 거에 대해서 궁금한 게 생겼는데, 아까 전에 제가 제대로 들었는지 모르겠는데 삼성 파운드리를 사용한다라는 얘기를 들은 것 같은데, 그러면은 센터에 혹시 제조 프로세스 엔지니어를 뽑을 계획도 들어가 있는 건지 아닌지 궁금하거든요. 여기서 만약에 파운드리 사용한다고 하면 거기에서 프로세스 아키텍처라든지 아니면 QA 같은 거를 담당한 사람들이 있어야 할 것 같은데, 혹시나 저는
Your engineering center gets some plan. Do you plan to employ CPU engineers and test engineers and service engineers in Korea?
So we already have one, maybe two CPU designers here. As I said, we're going to start with AI software, but I think it would be talent-based. The plan right now, no, but given our relationship with Samsung foundries, etc., if we have the right candidate talent pool, I think we're open to it.
지금 현재 엔지니어링 센터에서 한두 명 정도의 CPU 지금 엔지니어들이 있는 걸로 채용 중인 걸로 알고 있고요. 그러면 저희도 삼성 파운드리와의 관계도 있기 때문에 시장에 있는 인력들의 상황을 보고 또 그때 맞춰서 결정하면 될 것 같습니다.
네, 감사합니다. 저희는 시간 관계상 질문은 여기까지만 받겠습니다. Due to the time constraints, the Q&A session will be concluded. Thank you for your enriching presentation. Thank you. 네.